Okay, so today our goal is to do a review of the three basic trig functions. We're going to look at their definitions, and then we're going to look at a word problem that demonstrates how to utilize these trig functions. Um, so here we have a right triangle, and whenever we talk about these trig functions, they're all based on the angle to which we're referring. So we'll look at this angle here and call it angle A. And based on where I've placed angle A, all three sides of the triangle are now defined. So for example, based on where I've placed A, this side would be considered the adjacent side. And the side over here on the other side of the triangle is then called the opposite side. And because we're dealing with right triangles, we now have a side that is called the hypotenuse. And because we have all three of those sides, we have now defined all three trig functions for angle A. So we've learned before that sine of A is the opposite over the hypotenuse, and the cosine of A is the adjacent side over the hypotenuse, and the tangent of A is the opposite over the adjacent. And we have a nice little mnemonic device for remembering this, which is SOHCAHTOA, where sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is the opposite side over the adjacent side. So this is just a review of the three ratios we've learned before. So now we want to take a look at an application problem that utilizes these trig functions. So here's what we have. We have a building 210 feet tall, casts a 90-foot long shadow. If a person stands at the end of the shadow and looks up at the top of the building, what is the angle of the person's eyes to the top of the building? We'll try to get it to the nearest hundredth of a degree. And we'll assume that the person's eyes are 4 feet above ground level. Okay, so we're talking about a building, and we have our building here, and we have somebody looking up at a building here, and there's my viewer. So we have to imagine that we have the sun behind the building here. There's our friendly sun, and is casting a shadow, and the sun's rays come here, but the shadow that is cast is along the ground. So imagine the shadow along the ground here that we can see, and the shadow apparently is 90 feet long. Okay, and we have a building that's 210 feet tall. So from top to bottom, the building is 210 feet. But recall that we're talking about 4 feet right here, which is the height of the person's eye. So even though we have a 210-foot building, we really are only looking up to 206 feet of it, because the extra 4 feet, which would be down here, is the height of the viewer. So we've started to define the aspects of a triangle here, and if we start to piece together, we can start to see where our triangle is, where we have a base here, and we have a height we're looking up at here, and certainly we also have a hypotenuse here. So we have a nice little right triangle that's developed based on where we have placed our objects here. Okay, and what we're looking for is, well, we're looking for the angle of the person's eyes to the top of the building. So drawing a good picture here is really of top importance. And since we've drawn a good picture, we understand that the angle we're looking for is right here. This is the angle where the person has to tilt their head to look up at the top of the building. So if you draw a good picture, it starts to become evident that we're going to use one of the trig functions, but which one are we going to use? And we saw in the last slide that if this is the angle, if angle theta is right here, well, which sides do we have? Do we have the opposite? Do we have the adjacent? Do we have the hypotenuse? And a little labeling goes a long way here. Based on where we placed theta, 206 feet is then the opposite side, and 90 feet would be considered the adjacent side. So we have the opposite side and we have the adjacent side, and we ask ourselves, okay, well, which trig function utilizes opposite and adjacent? And since we've become proficient at SOHCAHTOA, we know that that is the tangent function. So we're talking about tangent here. And we recall that tangent is the opposite over the adjacent. So now that we've drawn a nice triangle, a nice picture, we can just start to put these things in. We have tangent of theta equals, well, our opposite side is the 206, and our adjacent side is the 90. So here we have two of the three things we need. We have the opposite, we have the adjacent. We're looking for theta, and we're looking for specifically tangent of theta, but the way we solve for theta here is by using an inverse trig function. We'd like to isolate that theta. We want to get rid of the tangent. What we can't do is simply divide by tangent. We need to do its inverse. So the way it works out here is we have theta is the inverse tangent of 206 over 90. We want to undo the tangent function. And undoing here is the inverse. And this is where we use our old friend, the graphing calculator. and we locate the inverse tangent button, which is usually a shift button above the tangent. So we do the inverse tangent of 206 over 90, and we'll find, based on that, that theta is about 66 degrees, which means that right here we're looking up at the top of the building at a 66-degree angle.